Zep is a context engineering platform that can provide your agents with a unified, long-term context store of chat history and user interactions. On every chat turn, Zep retrieves the most relevant information to the current user message from that user's Zep knowledge graph to improve the personalization and reliability of the agent's response. However, it's often useful to have complete control over the context block that you provide to your agent, whether to optimize your token usage or to adapt the context block to your domain to improve performance. In this video, I'm going to show you how Zep's context templates make it incredibly easy to customize and iterate on the type of context you provide your agent. Using Zep's context templates, you can define which artifacts from the knowledge graph to retrieve and how many results you want, as well as what the surrounding context template should look like. In this example, we are specifying that our context block should contain a user summary, 4 facts which come from the edges, and which should only consist of the has requirement or prefers neighborhood edge types, as well as 3 entities and 2 episodes. As you can see, these context templates use a declarative template syntax that allows you to focus on engineering context without worrying about the information retrieval logic and parallelization that occurs under the hood. Once you have defined your context template, you just use Zep's SDK method to save this template with whatever template ID you want to use. Then, in the implementation of your agent, you just provide the template ID that you've defined when retrieving the context block from Zep. And instead of returning Zep's default context block, Zep returns a context block that adheres to the template you've defined. As you can see here, the context we provided to the agent fits the template that we specified. Context templates are especially powerful when used with Zep's custom ontology feature, since you can specify in the template which custom entity or edge types to filter by. In our example, we were filtering to the has requirement or prefers neighborhood edge types. If you aren't familiar with custom ontology in Zep, you can read about it in our documentation here. Essentially, you can define pydantic-like classes that all new entities and edges in the knowledge graph can be classified into, according to your custom descriptions. This allows you to define the most important concepts for your domain such that these concepts are captured and tracked in the graph, ultimately allowing you to construct your context block filtered to these concepts using a context template, which can significantly improve the reliability of your agent in your domain. Context templates are also helpful when iterating with Zep to achieve optimal performance while minimizing token usage, and so we highly recommend using context templates when using the Zep evaluation harness. The evaluation harness allows you to quickly evaluate Zep's performance for your use case by simply providing a few examples of the kinds of responses you want your agent to have when connected to Zep. If you're not familiar with the evaluation harness, you can read about it in our documentation here. Context templates represent an important step toward making context engineering simple and effortless. The declarative syntax allows you to quickly iterate and find the ideal context structure for your use case, so you can more easily improve the personalization and reliability of your agents. To learn more about everything else the Zep platform can do, check out the Zep documentation.